Good day to you wherever you are watching from. In this um, video, I would be explaining how to run analysis of variance on SPSS. And if you recall, um, I had done a video to actually explain the theory of analysis of variance. So we already have an Excel sheet that contains our data. So the first thing we have to do is to find a way to export the Excel sheet from the back end of our wherever it is stored. Uh, Mine is in the download. So I will open the download now, and it's good to see which file type. There is SPSS. So the file type I'm looking for is the Excel type. So if you don't select the file type, you might not get what you actually desire to see. So I've selected the file that contains the data I'm interested in using. So I have clicked on it. So it is expected that the data shows. Okay, what it's saying is that that data that I'm interested is actually being opened somewhere. Okay, let me see. Hmm, think I opened anywhere. Excel sheet open. All right. Let me try again. So you go to open, then data, then the type of sheet I want is Excel. So I'll go and look for it and pick it wherever it is. Okay. So I'll just say okay. When I say okay, it will just take me to where the data is and be able to open it. So you can see now that the data that I have is three different teaching methods and the achievement of students exposed to it. There must be independence of group such that there were 30 people exposed to the first teaching method and the other one is activity based. You have another 30 and the final teaching method is the blended approach which we have 30 and here we have the achievement score. So this group of students are independent. That is the first assumption. So straight away we could go to the teaching method section and do the value. Uh, Although it's already written there, but I just want to do it again. Let's go back. Uh, Your lecture is one. We give lecture one. Value lecture is one. Next one, two is activity based. Three, three is uh, three is blended. So that's so we say okay. You may also do the label. Here is the achievement and just copy Control C, put it here to V. You can also copy from here, Control C and put it here, Control V. Yes, you can see that the scale of the independent variable is nominal, while this is on scale. You can see that we could ignore the numeric value of the student's identification. So having done that, the next thing is to start to analyze as well. So when we start analyzing, we go to compare means. And when we go to the compare means, we go to one way Anova. So we click on it as it were. When we click on the one way Hanover, um, something is not right. Okay, okay. Let me go back to the variable view and what happened here is that the we had already removed. I'm trying to, the way we coded it, we had removed the, we had already put the data as, so let me change this uh, to 1 so that it will read from the back end like that. So this lecture is 1 all through. Then the next thing is activity based control. Let me just say, so, so copying the two, then I'm putting it all through where um, control V, 2 is everywhere there. Then the final one is the blended, which is 3. Do 3. I'm saving it, Control C, and I'll just put it in that place here, Control V. So, so I think I've tidied that up. So I will now go to compare means and one way and over and see what happens now. Okay, the student side is not coming up. Um, I'm deliberately leaving the video like that. Okay, let me see what happens. Oh, let me and come here. This is our dependency, but the factor is not actually showing. Um, okay, I deliberately left this video like that because things like this could also happen to you when you're doing your data. So I want to quickly change what I have on that end to another section, which is Control V. So I want to rename this to, okay, I think I know the problem now. This is supposed to be numeric. So I have put it numeric. Okay, so it's now numeric. Let's see whether it will run. Let's analyze, compare means. Yeah, I think it's okay now. Now have a numeric value. So I deliberately allowed the computer. I should have cut the video, and so what I did was that the teaching method is now showing as it ought to be before now. you know. I made some adjustments, but now I want to stay by what I had before. So this is numeric, let's say that, and yeah. So we have numeric, not string type of data. So the numeric as we have it, we could actually we could so we already put numeric. So instead of allowing the SPSS to do the job, I want to put the real value. So 1 is already um, 1 to 30 is the lecture, and 231 is the activity based, and 3 is the blended approach. Well, so this is 3. You're putting it all there to see what we will now have. Okay, so we can now go to analyze and compare mean and do one way Anova and see. So you can see that inside the dependent list we put our achievement. In the teaching method we put the factor as it were. So we can decide to do a post hoc, but the first place I went to now is the options. In these options, I will select on descriptive. I will select on homogeneity of variance test. I want to be sure. Then I will select on mean plots as it were. Um, then I will do a post hoc, which I will explain uh, very well subsequently. Um, but the point is that for now, let me just select Shefe. I told you in the earlier video that there are assumptions for the selections of the type of um, test that we would run. So basically, uh, in this particular one, we just say okay. We are good to say okay now, and we'll have an output. Then I would love to start a conversation from our outputs. The computer did not do well because the coding we did at the back end was not actually acknowledged. Yeah, it was not acknowledged. So I want to redo it. One is lecture. Mhm. Two is activity based. Yeah. Three is um, mm, blended, so that the number the output did not come with those names because I deleted them. So I'm doing it. I did it again. So let me run analysis and compare mean and see now the output will give me the right names that I wanted. Yes. Okay. Okay. So this is my first output. Yes. But this second one, you can see the first one here just had numbers like that, 1, 2, 3. But when I went to put the name, I now have I could have stopped this video and uh, do a cleaner one, but I just want you to see the process that we have to see there. So let's start from here. You can see that the guys who are exposed to lecture, they had a mean score of 68.87. Those exposed to activity based, they had a mean score of 68.30. And the people exposed to a blended, they had a mean score of 68.33. So it is clear now that uh, we have that. Then this is test of homogeneity of variance. The assumption of Anova is that the variance in the groups are equal. That means the two groups, they have equal amount of variance. So this test, you just look at the significance. The level of significance is 0.389. So as a result of that 0.389, the is greater than 0.05. So the Levene test is showing us that the variance in the group are equal. So we can go ahead. If there is a situation whereby what we get here is less than 0.05, it is wrong to proceed with Anova because this is indicating that the groups are not equal. Although so many times these details are not usually asked for. So the next thing is the F value. Look at it here. F is 0.014. So it means this is the F test that we actually do. It means that uh, the group, the mean score of the three groups are significantly different. And if you look at the data closely with just mere looking, you will assume that they are very close. 68.87, 68.30, 68.33. All of them are 68. But the F value here, because our P, sorry, the F value, the P value, that's where I was supposed to look at. The P value, not the F. The F value is the F test. Now the P value is showing us that we have 0.986, meaning that the value that we obtain is greater than 0.05. It means that they are not different from one another. There is no significant difference for this group. Let me emphasize it again. You look at the significance. If the significance is less than 0.05, it means that the group are significantly different. But look at this. They are not significantly different from one another. That's the meaning of this 0.986. And because we have this 0.986, we don't need to bother ourselves about shaping. It is when we have a significant result, we do a multiple comparison. So in the next video, we will use a set of data that will just to do a multiple comparison of our results so as to determine whether they are significantly different or they are not. Thank you very much. See you in another video, as it were.